What I want to do as a precursor, though, is I just want to go and show a few shortcuts, if I may, that may assist. And one of these is the knowledge about amplitudes and translations. Just as a precursor, I've got this function here, y equals 2 sine 2 brackets x plus pi over 3 plus close brackets plus 1. You'll notice there's scribble all over it. This is because I was doing this in class. This is a graph that's been moved to the left by pi on 3, and also it's been translated up by 1. So here's the graph of that function, and you'll notice there the uppermost points is up at 3. You'll see it there, that's the uppermost. The lowermost points, so the lower turning points, are at -1. Now, it's quite simple to do that. When you're preparing for it, you can see how much you're going up by. The middle would be 0, and you move that up by 1, and then you move the topmost because the amplitude is 2, and you move that up by 1, and then the bottommost would be -2, and then you move that up by 1. Well, there's also a very quick and cheap, if I like to say, if I can use such a word, way to discern where the top and the bottom would be very quickly. And that's this little trick. We just have to replace the entire sine function with the number 1. If I do y equals, so for the maximum, 2 times 1, so the entire sine function plus 1, and that gets me 3. So why do I do 1? Well, a regular sine function without any translations whatsoever, and when we normally draw it, so whoop, usually has, usually would be like pi on 2, would have a value, a y value of 1. And similarly at 3 pi on 2, it would have a value at -1. So that's why we can replace that with 1, and it will achieve the same goal. So you can imagine for a minimum, if I did this, 2 times -1 is -2 plus 1, -1. And we have very quickly and easily found our maximum and minimum. This is yet another very typical trigonometric question. It's usually involving particles moving as well. So a particle moves on a straight line, OX, and its distance in x meters from O at the time t seconds is given by x equals 3 plus 2 sine 3t. So first and foremost, this confuses everyone because of x's and t's. Second thing, it has been translated, but only vertically translated. So we can use our little trick that we established in the prelude if we ever have to find a maximum or a minimum. So it probably would help here if we understood what this question was actually meaning. What is an OX? What is this particle doing? Well, it's going on so you can imagine a straight line. The particle is moving backwards and forwards. That's what I think is the thing that is always missing in these sort of physics-y type questions, is what is it doing? It's moving backwards and forwards in a trigonometric fashion or a periodic fashion. And so we have, what we have discovered is that using this equation, we know when it's the furthest away from the origin. So imagine like this end is the origin, this is O, and this end here is how far away it is. It's going there, and it's coming back, and it's going there, and it's coming back, and so on. So when it says find the greatest distance, we don't want to think too hard. That's clearly going to be the maximum. And similarly, spoiler alert, when we see least distance, that's going to be the minimum. Now we can hereby use the trick that we did in the prelude to be able to solve this question. The maximum distance is going to be 3 plus 2 times 1, which is 3 plus 2, which is 5, is it meters? Yeah. So 5 meters away. Similarly here, we can just times by -1. And that's going to be 1 meter. And that's just a very quick way to find the top and the bottom for this particular equation. Find the times at which it is 5 meters from the origin for 0t to 5. So now we need to solve. So let's see if we can solve it now without the aid of a calculator. Well, 1 is an exact value. So when is sine equal to 1? We just need to remember our unit circle. And in this instance, the unit circle, remember that cos is the x value, sine is the y value. This will be when t is pi on 2. So we are going to solve as usual. So it's positive. It doesn't really have a quadrant here because it's right in between two quadrants. So I'm just going to go straight to saying the reference angle, which is pi on 2. The domain, so my existent domain, what is between t is from 0 to 5. So it says here 3t here. So we're going to multiply both sides by 3t, which is 15. So it's worthwhile knowing what pi is approximately as a whole number. And pi is 3 and a bit, so 3.1. So what I'm going to suggest here is that how many times can 3 fit into 15? Well, that can fit into 5 times. So because it's 3 and a bit, it's definitely going to be less than 5 times. So I'm actually just going to say, as a rough guide, that the domain is between 0 and somewhere less than 5 pi. That's what I'm going to suggest here. So 3t is equal to pi on 2. We go around the circle again. And so we've got pi on 2. We have to go around the circle again to the next one, which is 5 pi on 2. Because 5 pi would be the next time around the circle. And so that's going to be 9 pi on 2. So then, just need to divide everything by 3. T is equal to pi on 6, 5 pi on 6, 9 pi on 6. Of course, 9 pi on 6 can be simplified. So that can be equal to pi on 6, 5 pi on 6, and 3 pi on 2. To double check, we need to sort of go and make sure that our t values are somewhere between 0 and 5. So what is 5? 5 would be greater than pi, but less than 2 pi. So it's somewhere in between because pi is 3 and a bit. 2 pi would be 6 and a bit. So it's somewhere in between. So let's have a look. Pi on 6 is definitely less than pi. 5 pi on 6 is definitely less than pi. And 3 pi on 2 is actually smack bang in between pi and 2 pi. So I reckon we're pretty on the money. So the only thing I would do is just to double check that I am right on my CAS calculator, because I'm still learning at this point, and I'm right. So there is my solution things solved there. You'll notice there, of course, I've made sure to restrict the domain. And I've kept my answers on standard. Find the times at which it is 3 meters from the origin between 0, t, and 3. So we'll do the exact same procedure as we did before. So now we've got a situation where we have solved it and we've got sine equals 3t is equal to 0. So really the reference angle is either going to be 0, or you could say all pi would be my two possible reference angles here. So as long as we know those, that will help. We want the domain is in between t and 3. So 3t is going to be between 0 and 9. Now 9 is going to be less than 3 pi because 9 divided by 3 is 3. So it's going to be a little bit less than 3 pi. So therefore, if it's a little bit less than 3 pi, the values that I'll need here will be, 1 would be 0 because it has to be between 0 and 9. 0, it'll go once around to pi. It'll go once around again to 2 pi. but it's not going to be at 3 pi. You can certainly put 3 pi there, but you'll realize it won't be in the domain. So I am not even going to give it the time of day. So this becomes t is equal, so we divide everything by 3. And this becomes 0 pi on 3 and 2 pi on 3. And 2 pi on 3 is definitely less than pi. Yes, because we want it between 0 and 3. And so that is definitely less than pi, so therefore it is likely to be less than 3. Once again, we can always double check on the cas. And there we go, 0 pi on 3 and 2 pi on 3. Describe the motion of the particle. Now this one's a little bit harder because it's a little bit more vague, and the textbook likes these sorts of questions. However, if this was given in an exam or any other situation or a practical situation, it's best to make sure that we use as many specific values as we humanly possibly can. It would be advisable to draw just a very rough sketch so you know what it looks like. We know it's been moved up. We know the minimum is 1, the maximum is 5, and so therefore the middle is 3. And it's not an upside down graph at all, is it? No, it is. Yeah, it's just a regular ordinary graph. So it looks like this. So what does it mean in reality? So this question is asking, what does this graph mean? Well, the 3 there is where it starts. So the particle is actually starting 3 meters away from the origin, and then it's going on a straight line to 5 meters away from the origin, going back to 3 meters on the origin, then going to 1, so 1 meter away from the origin, and then so on. So I would describe the motion of the particle. So the particle moves from 3 meters from the origin, which we've already established is O, to 5 meters away, back to the origin, to 1 meter away, in a periodic motion. That's how I will describe it. Then we could also describe its distance as well. So on average, the particle is 3 meters away from the origin, because it always keeps coming back to 3 meters, and then it gets 3 meters closer, 3 meters away, and so on. So therefore, we could say on average, the particle is 3 meters away from the origin. So the more that you can describe what's happening, the better. I think the textbook answer will say just the last sentence, that on average, the particle is 3 meters away from the origin, because it's just wanting the middle bits. I don't think it's terribly bad to mention the rest of it, because the more specific you are, the better the answer is. So, but nonetheless, it's not something that we focus terribly much on in Year 11. But if there is an awful question like that somewhere, it's worthwhile describing it, and also making sure that you get the practice of saying things specifically. The main thing to get out of this is that you want to make sure that you describe things specifically. So it's no point saying, it moves trigonometrically. Yes, I can see that. Tell me what that means. What specificity that you have. The more that you can say, the better. And especially if you're using your previous answers.